Warning, the content of this video is purely speculative, nonsensical, and holds no scientific weight. Please consider this a disclaimer before watching. And once you've finished, please don't complain about how delusional or irrational it is. Hello everyone, it's great to have you back for another journey into the mysteries of the cosmos. Much like a video game or a mobile app, the universe and everything within it operates according to specific laws, principles, and fixed variables. If even one of these variables were to shift, billions of things would instantly go haywire. So, what would happen if you possessed a magical machine? A device that allowed you to arbitrarily change the fundamental parameters of the universe, for instance, swapping the speed of sound with the speed of light. What would that mean for humanity, for the Earth, and for the entire universe? Welcome to Universe 48. What exactly would happen if the speed of sound and the speed of light traded places? According to Wikipedia, the speed of light in a vacuum, denoted by the symbol c, is a crucial constant in many fields of physics. Its exact value is 299,792,458 meters per second, which is approximately 300,000 kilometers per second. However, light doesn't always travel through a vacuum, and therefore, it doesn't always maintain that maximum value. Depending on the characteristics of the medium it passes through, light has a different refractive index, which translates to a different propagation speed. For example, the refractive index of light in air is 1.003, meaning its speed in air is roughly 299,910 km per second. Similarly, the refractive indices for water, glass, and diamond are 1.3, 1.5, and 2.4, respectively, resulting in speeds of 230,769 km per second, 200,000 km per second, and 125,000 km per second. Most notably, when light passes through matter in a Bose-Einstein condensate, a state of matter where gas is cooled to near absolute zero, or minus 273.15 degrees Celsius, its speed can drop to just a few meters per second or even come to a complete standstill. In the same vein, the speed of sound depends entirely on the properties of the medium through which it travels. The figures we usually take for granted, like 343 meters per second or 1,235 kilometers per hour, only apply to dry air at 20 degrees Celsius. In water, the average speed of sound is 1,481 meters per second, in an iron bar, it's 5,120 meters per second, and in a diamond, it reaches a staggering 12,000 meters per second. That is 4.3 times, 15 times, and 35 times faster than the speed of sound in air, respectively. To keep things simple for this video, let's establish that regardless of time, space, or circumstances, the speed of sound is 343 meters per second and the speed of light is 300 million meters per second. Now, let's swap them. In a world where the speed of sound is roughly 874,635 times faster than the speed of light, your reality would be flipped upside down. You would hear the thunderous boom of a lightning strike long before you ever saw the flash. You would experience a noticeable lag from light bulbs. When you flip a switch, you'd have to wait for the light to actually reach your eyes if the source is far away. Sunlight, which currently takes about 8 minutes and 20 seconds to reach us, would now take a grueling 13 years, 10 months, and 10 days to travel from the sun to the earth. Conversely, if you were to let out a loud enough sound, and I mean exceptionally loud, everyone across the globe would hear it instantly without any delay. This is because sound waves would now be capable of circling the Earth's equator 7.5 times in just 1 second. Looking at the bigger picture, light from distant stars and galaxies would take so long to reach us that the night sky would be significantly darker, especially on moonless nights. This would also cause the diameter of the observable universe to shrink catastrophically. It would drop from 93 billion light-years to somewhere around 106,330 light-years. The number of stars you could count in the sky would dwindle to almost nothing. Our neighboring galaxy, Andromeda, would become something entirely unknown to us, simply because it sits 2.5 million light-years away. In this fictional world, humans would only be able to observe objects within a maximum distance of 53,165 light-years. With such a limited field of vision, humanity might very well conclude that the Earth or the Sun is the absolute center of the entire universe. Speaking of light-years, a light-year is defined as the distance light travels in a vacuum over the course of 1 year. In this new world, a light-year would no longer be 9.461 trillion kilometers, it would be a mere 10.8 million kilometers. Furthermore, the Doppler effect, which we are used to hearing, would now be something we see. For those who don't know, the Doppler effect is the change in frequency of a wave in relation to an observer who is moving relative to the wave source. The most common example is a car passing you on the street. The sound of the car is higher pitched as it approaches and lower pitched as it moves away because the sound waves are compressed at the front and stretched at the back. The faster the car moves, the more pronounced this effect becomes. When the speeds of sound and light are swapped, the Doppler effect for sound waves would essentially disappear from our hearing. Instead, you would see it happening with light. Specifically, when you are driving down the road, the light waves in front of you would be compressed, shortening their wavelength and shifting them toward the blue end of the spectrum. This cool-sounding phenomenon is called blue shift, and it would make everything ahead of you look distinctly blue. Conversely, everything you see in your rearview mirror, the light waves behind the car, would be stretched out, increasing their wavelength and shifting them toward the red end of the spectrum. This is known as redshift, and it would make everything behind you appear much redder. If you go a bit faster, airplane pilots would have to rely entirely on radar and ultraviolet cameras. This is because the light waves in front of the nose of the plane would be so heavily compressed that their wavelengths would drop into the ultraviolet range, becoming invisible to the human eye. Even more depressing, the view from an airplane window, no matter where you sat, would be nothing but pitch black. Even if you wore special goggles to see ultraviolet light, the scenery wouldn't exactly be poetic. Back on the ground, everything you see that is 343 meters away would actually be an image of that object as it existed exactly 1 second ago. Similarly, the moon you see in the sky would be the moon as it was 13 days prior. And the sun, as mentioned before, would be the sun from nearly 14 years ago. But the complications don't stop there. Even if the internet cables weren't being chewed by sharks, the web would move at a snail's pace. A single Facebook message would take minutes to send. Long-distance voice or video calls would become utterly absurd, as you would have to wait an eternity after every sentence for the other person to hear you. Online gaming would go extinct because the ping or latency would be so horrific it would last half a gamer's lifetime. Expanding further, landing on the moon or exploring deep space would become incredibly time-consuming and dangerous missions. Communication in space via radio waves, which travel at the speed of light, would take far too long. A message sent from Earth to the moon would take 13 days to arrive. To Mars, it would take 7.5 years. To the Sun, nearly 14 years. And you would have to wait that same amount of time just to get a response back. Everything sounds pretty bleak, but we would actually be lucky if this were the only problem. In reality, we probably wouldn't exist at all. Imagine if the formula E equals mc squared still held true in this new world. The amount of energy the sun produces to balance out the massive gravitational force pulling everything inward would drop abruptly because c has plummeted from 300 million to 343 meters per second. Gravity would instantly win the tug-of-war. This means not just our sun, but every star in every galaxy across the universe would simultaneously collapse. This would trigger quintillions of supernovae of varying magnitudes, obliterating every planet capable of supporting life. Even if the stars didn't explode, the sheer lack of sunlight reaching us would ensure that humanity would soon join its ancestors in the great beyond. Fortunately, all of this is just a wild bit of speculation from a YouTuber. Alright, stop it. Stop talking nonsense. You're just making things up now. Laughter, music.